So it will be nice if you can have the perfect squares memorized, which is this column right here. So I would, write this out or print it out somewhere and then put it somewhere where you're going to see it a lot. Some students like to put it next to the John, whatever, okay? Just so, because that's, instead of reading the paper, you can memorize math facts, and it's so much fun.
I just watch your videos in the toilet.
All right, if you're going to memorize these perfect squares, this kind of stuff goes pretty nice. It goes pretty nice. But again, factoring by grouping, always a solid method for just factoring trinomials. Now, by the way, if you don't have these memorized, your calculator does. So you could just use a calculator if you wanted to. But so recognizing perfect square trinomials, two terms must be squares. We're looking at the two ends on this. Okay, so let me relate this to what we just saw from the last lesson, right? So you got ax squared or something like it plus bx plus c. Usually the a will be something that's squared, and then the c will be something that's squared. Okay? Which is why it's important to notice those perfect squares, which one is one of. So that's important to remember too. But this middle term right here has to be a multiplication of 2 times whatever this a is and then the c is. It's I'm oversimplifying this, but you'd have to square root them. I just don't want to say it out loud because it causes confusion. So in this format, we're kind of just looking initially to see if the leading coefficient and then the final term here are perfect squares. I don't really care about the middle one so much. We can figure that out as we go. If they are squares, and you notice that we've gotten rid of the x's, so the first term, this could be something like, for example, maybe I'll use 100. That's an easy one. 100x squared. Well, what you would do is you would take that 100x squared, and instead of writing it as 100x squared, you'd write it as two different factors squared, which would be 10 and x. Okay, so this we see that the 100 is 10 squared, which is important to notice. If it's like 25, it'd be 5 squared. And then usually the variable will be something that is squared as well. So if this happens, and then this term as well is something that is squared, then usually this middle one will be 2 times, again, the a would be like the 10, and then the b would be whatever this is as a square root, I guess. 2 times this stuff, and that would be your middle term. So you do kind of have to check the middle term, but if it is, you get to just write it in this format right here. A plus b squared, and notice it has to do with just this first one. The second one should always be plus. The second operation should always be plus, but our first operation, it can switch. If it was minus, then it's minus between in the binomial. If it's plus between in the binomial. But again, if you wanted to factor by grouping, because it's so much fun, do it. If you start with something that's not a perfect square in the front or the back even, look to factor with the greatest common factor first, which is, again, it's something you should always do when you're factoring. Look at your trinomial, see if there's something you can factor out of all 3 terms, get that out of the way, and then usually something else will pull up that hopefully is a little bit. Okay, so I got my rules up here so I don't forget, and we can don't get the buzzer if you know what I mean. So on this one, which is fine, So on this one, okay, so I don't really care about the negative 72. I'm just looking at my ends here. I got 81 and 16. Even the x squared is kind of important, but I know the 81 and 16 they're both perfect squares. So let's see what this is. Okay, so I'm going to rewrite this. I'm rewriting the same exact expression, but I'm rewriting it in a different way so that we can see these perfect squares as their bases, right? So for example, 81, that would have been 9 squared, but the x is squared as well, so it's really 9x squared. I'm doing more work than you'll need once you get enough experience with this, by the way. And then the 16, that would have been a 4. I get the 4 on there. There we go. 4 squared. So I see that the two end terms are perfect squares. Even the x squared is a perfect square. All right, well, what about that middle term? Well, it's negative 72. But all I really care about is this 2 times the a times the b? Well, that would have been 2 times 9x times the 4. Which is, now it's 72, right? It would be 72x if you multiplied all that stuff. I don't really care about the minus sign, because now that I see that the middle term actually is 2 times a times b, I know that my perfect square binomial is going to be squared, but the minus sign up there tells me that it's going to be minus here in between. Well, what are we minusing? The a and the b. Now, if you really wanted to have fun, which I'm not going to do, you could factor this by grouping. And it is. It's so much fun. But the rule is nice because we found something pretty quick. The only check we really needed right here was this one. But you could separate these and then remultiply them with factoring. I'm sorry, with distribution or FOIL. And then you'd get the original expression there. So yeah, if I didn't, let's say that I had 60 right here. 60 is not a perfect square. Okay, I could factor out a greatest common factor, but that probably wouldn't help me in that case. I would have to use factoring by grouping. But by the way, make sure you always check, on the inside here, that there's nothing that can still be like a greatest common factor, that there's nothing to factor out there as well. And between the 9 and 4, there's just the one x, so I know I can't factor that out either. Looking at the 9 and 4, these are perfect squares, which means something later on. It's part of this lesson, but later on. But the x is not squared, so I don't have to worry about that garbage.